What's in the other side of a black hole? Fair enough, you would still be devastated. The broad consensus is that all matter dragged into a black hole would be compacted into a single point in space called the singularity. The precise fate of matter swallowed into a black hole is still up for debate. A back exit would give the material somewhere to go instead of being utterly destroyed. It's a crazy notion. However, wormhole theory has before taken odd detours. The fundamental idea is that a black hole's gravity is so powerful that spacetime itself is bent. Imagine the entire cosmos as a piece of paper. Two non-continuous pieces of the paper touch if some force folds a portion of the paper. If an object on one side of the sheet crosses the fold, it remains on the paper but is moved away from its original location when the sheet is straightened out. Assume for a moment that the paper now incorporates both space and time. Theoretically, a traveler could wind up at a different time if the wormhole's two endpoints are close to one another. For obvious reasons, the wormhole frequently appears in science fiction. But it's also a rather well-established concept in real science. Rather than connecting various regions of the same universe, Einstein's wormholes are frequently characterized as connecting multiple universes. Using the sheet of paper analogy once more, picture how two spots on separate sheets of paper are brought together by a powerful force. As a result, an object at the connection point could move from one sheet of paper to another, or even into another universe. It might even be feasible to travel back in time to a distant universe by fusing the ideas. Sadly, despite offering more theoretical understanding of the nature of black holes, the new finding does not make interstellar travel feasible. Even if black holes are always open wormholes, as has been proposed, nothing could pass through intact without being crushed. The black hole would spit matter out the other side, but not in the same state as when it entered. Furthermore, any wormhole could not be opened for more than a single instant due to the extreme gravity. However, there is no meaningful way to be certain without trying. The ensuing uninhabitable black hole's gravitational pull would be so strong that not even light could escape it. There is no escape if you end yourself at the event horizon, which is where light and matter can only travel inward, according to German astronomer Karl Schwarzschild. According to Massey, tidal pressures would turn your body into strands of atoms, a process known as spaghettification. Eventually, the object would be smashed at the singularity. It seems completely impossible that you could suddenly emerge anywhere, perhaps at the other side. In fact, in his book The Science of Interstellar, Thorne, who provided expert guidance to the interstellar production team, wrote, "We see no objects in our universe that could become wormholes as they age." Thorne told Space.com that travel through these hypothetical tunnels would probably remain science fiction, and there is certainly no solid proof that a black hole could permit such a passage. There seems to have been some confusion caused by the term black hole. Additionally, the visuals of a black hole's gravitational well don't appear to be any more helpful. I know that many people think of these things as amazing doors to some other planet or dimension from all the correspondence I receive. That they might serve as portals to experiences with gorgeous, sparkling people wearing strangely fitting chainmail and bikinis. So, where would you emerge if you fell into a black hole? What lies on the opposite side? Where are they transporting you? In reality, black holes don't go anyplace. There is absolutely no hole at all. They are enormous black orbs in space with irrational gravitational fields. Things that are black are commonplace, such as asphalt or your favorite Cure shirt from the Wish tour that has only ever been hand-washed. Black holes aren't really so dark. Even light, the fastest object in the universe, has given up trying to escape their incredibly strong gravity, which is why they are dark. Let's try to provide some context. Think about this. Imagine being able to lift an elephant on your shoulders. Even better, picture yourself donning a full elephant-like a suit. Let's now leave the couch and take a stroll. This is how it would feel if the Earth's gravity were multiplied by 50. The gravitational pull around your sofa would be billions of times stronger than what you would feel when trapped inside an elephant suit if we were to raise it to a level close to the weakest black hole. Therefore, if you entered a black hole while riding a space dragon, armored with punchy Maximus power gauntlets, and brandishing some ridiculous light-based melee weapon, you would be instantly transformed by the terrible tidal forces, which would unravel your body into streams of atoms, adding your mass to the black hole. Just to be clear, you do not leave the area. Simply put, you join the black hole. It's comparable to pondering where in a mythical world you would end yourself if you leap into a trash compactor. The outside universe would observe you approach a black hole more slowly and more slowly as time walks close to its event horizon. Theoretically, it would take an eons of time for you to merge with the black hole from their perspective. Even the photons that reflected off your newly shaped body would be stretched out to the point where you would start to turn redder and redder until you simply vanished. Even though space-time has been warped into a black hole's mouth, light still moves in a straight course. Even if you're a photon of light traveling away from the black hole, all routes lead directly to the singularity as you enter the event horizon. It has a horrible sound. The good news is that you and your space dragon die quickly and painfully from your point of view. So, if you have any plans to enter a black hole, I strongly advise you to think twice. This isn't a shortcut to another location in the universe or to a more advanced state of consciousness. Nothing exists on the opposite side. Just death and deconstruction. Black holes are extremely hard to find and are so dense that light cannot escape from them. Black hole radiation bursts can be seen by satellites orbiting above the Earth's atmosphere. There may be tens of millions more stellar black holes in the Milky Way, where dozens have already been found. We imagine stars to be similar to our Sun, one of 150 billion stars in the Milky Way, one of the hundreds of billions of galaxies that make up the cosmos. Compared to Sun-like stars, large stars burn their hydrogen fuel more quickly. As the fuel supply runs low, gravity starts to squeeze the cores of these stars, igniting new reactions in ever deeper shells. When an iron core reaches a certain size, it collapses and a shock wave causes a supernova explosion, destroying the outer layers. Light cannot escape because gravity becomes so intense at the center. A distortion in spacetime brought on by large objects is called gravity, and Albert Einstein's equations describe it. How distorted can spacetime, though? A red giant star with 1,000,000 times the mass of the Earth could, in the most severe scenario, collapse into a volume 1,000,000 times smaller than the Earth. As you go closer to the mass concentration in the center after entering the warped space, you feel the pull of gravity getting stronger and stronger. You finally arrive at the event horizon, the end of the road. The supermassive black hole that the galaxy's stars orbit is another form of black hole that can be found close to the core of most galaxies. A 4 million solar mass black hole at the heart of the massive galaxy M87 is one of the largest. What is the origin of these supermassive galaxies? Supercomputer simulations were used to mimic the circumstances surrounding the Big Bang, which is thought to have created the universe. According to the scenario, gravity started to bring the gases of the cooling cosmos together a few 100 million years after the Big Bang. The earliest enormous stars were created as clouds expanded and heated up at their centers. Large black holes were left behind in the early universe by the supernova explosions that killed these stars. A spacecraft by the name of Swift travels through space and through time to observe these ancient stars exploding in supernovae. The black holes grew bigger as they moved toward the centers of their fledgling galaxies, snatching up stars and gas clouds in the process. The black holes at their centers united to grow into larger black holes as galaxies joined together. The Milky Way galaxy's central black hole has been sought after by astronomers. About 2/3 of the way from the Milky Way center to its edge, we are situated. Our ability to see the core is obscured by stars and clouds of dust and gas, but sensors can detect radiation that we cannot. In a region known as the central bulge, star density rises as you approach the Milky Way's core. Gas remains from previous supernovas and spinning gas clouds can be found closer to the center. Stars fly close to the center, around an invisible mass. We can experience what it might be like to enter the black hole through computer simulations. A disk of gas surrounds the hole and is plunging toward the center. However, as the gas collides with itself, a significant portion is pushed away and forms jets that are racing outward. Space is distorted and takes on the characteristics of a lens as we go closer to the event horizon, which is the boundary beyond which nothing can cross. The black hole's center contains a point known as a singularity, or a point of infinite density, and as we descend below the event horizon, we observe a storm of energy and matter continuing to plummet there. A wormhole's opening may be found in the storm's eye, which would allow material to travel there from a white hole at the other end. A white hole might act as a portal to another universe. Only lately has the existence of black holes been established. Naturally, whatever we know about them comes from our observations of them. The Milky Way galaxy's center contains the nearest black hole to us, yet there is too much matter between us and it for us to see it. All of the information we have about black holes is theoretical. Black holes defy the laws of physics, making them a mystery. That is, where singularity exists, space and time begin to skew once you pass the event horizon before they completely vanish. It is unknown what will happen to matter when it encounters the singularity. The bottom of a black hole is thought by some scientists to be a portal to another dimension, while others say it leads to another universe. Of course, no one is certain and probably never will be, as we simply cannot get close enough to determine these things. That black hole is thought to resemble a giant garbage bin. The majority of what is put in is eliminated. What are black holes? They defy the fundamental principles of physics and our knowledge of the world. As far as we are aware, there is nothing on the other side. As previously stated, everything is theoretical, and the only thing we actually know about black holes is that they have a strong gravitational pull and are the reason why our galaxy spirals. You might be seeing the postulated wormholes when you say it takes you elsewhere, which varies greatly. Leave a like for the algorithm if you haven't already, leave a comment below and share your thoughts.